So today is the 19th day of the main LeetCode 30-day challenge. And the problem will be online stock span. So we are asked to write a class stock spanner which collects the daily price quote from stock and returns the span of that stock's price from current day. And the span of stock's price today is defined as the maximum number of consecutive days starting from today and going backwards, for which the price of the stock was less than or equal to today's price. Okay, so for example, if the price of stock over the 7 days were like this, then the stock spans will be for 70, because 70 and 60 consider itself and the day before 70, which will be 2. And consider 75, 60, 70, 60, which will be 4, and consider 85. The maximum span will continuously form from 85 backward to 80. So how do we solve this problem? Basically, this problem can definitely solve via the brute force solution, and for each price we into the query, we just go backwards until the first day, or where the continuous smaller is break, and this will definitely get TLE. So we can optimize with this technique called the monotonic stack, which can be solved in the linear time and linear space. And the monotonic will be descending for the stack back, which will be the biggest, and for the stack front, which will descend to the smallest. And let's see how this works. So you can see like we can use a pair, which is the price and the count. The price is the current price and the count is the continuous lower days before price I. So each time we are in the query is the next. Each time in the query next, we can write a function in that query be like this. The pseudocode will be like this. So if the stack size is not empty and the stack top is less than or equal to today's price, because the problem is asked to write that less than or equal to. So we used a variable called the counter. The counter is the continuous lower days before price I. So counter will plus equal to stack top second. And what is this? This is the consecutive lower price for price I minus 1, which is the current price, which is the latest price before today. So we can definitely get the current consecutive day plus the yesterday's. So if yesterday's price is lower than today, then we can add it up to form a bigger answer or the bigger count. And stack pop, which pop for the next element, and counter increment for 1 day, and the end. So let's see how this works in the animation. So I will write and trace. Okay, now see how this works. So in the first day, the input price is 100. So here we'll push 100. And since the stack size is empty, which will not go into this part, and we will just push 100 and counter is now 0 into here, because there are no consecutive days which is lower than or equal to before this day. And second day 80. So the situation is saying like yesterday, but the stack size is now non-empty. However, the price today is 80, which is definitely lesser than top. So the while loop will not go in. So here we push 80 into it. 80 and 0. And finally, now we have 60. and 60 is the same situation as 80, so we simply push 60 and 0. And now we have 70. In 70, the situation will be changed. The stack size is now non-empty, and the stack top price, which is 60, is lesser than or equal to 70. Because we want to keep our stack from stack back to stack top in the descending order, so we have to pop 60 out. So the 60 will be popped out. So now the while loop is at here, and counter will be increment to 1. And counter will be 0, and counter plus equal to 0 is 0, and stack pop, and then counter increment to 1. So finally, we return counter plus 1, y plus 1, because the function defined as including today, so we have to plus 1, which represents today. But we cannot push counter plus 1 into the stack, because the stack counter is defined as the continuous lower days before price I. So we have 70 and 1 here. And now 60, 0, and at 75, things will get more interesting, where now 2 of them will be popped out. So we pop out the first one, and the counter is now 0, and then counter increment to 1. So counter change to 1. And then we pop 70 out. The counter plus equal to 1 will be, the counter will be changed to 2. So counter will be 2. And then finally counter increment by 1. Then the counter will be 3. So the counter will be 3, and then we push 75, 3 into this stack, and the return will be 4, because 3 plus 1 is 4. So till now we have the return as 1, 1, 1, and here 2, 1, 3, and the last one is 85, and we still haven't do it. So, oh sorry, and then the last one is 85. So since 85 is greater than or equal to 75, so we simply pop 75 out. So the counter will now become 0 plus 3, which is 3 at here, and then stack pop. So the 75 is being popped out, and then counter plus plus. The counter plus plus will make counter to be 4. And then the stack top will be 80, and 80 is lesser than or equal to 85, so we still go into the while loop, and counter plus equal to stack top second. So the stack top second is 4, and is 0, so counter is 4 now, and stack pop, so pop 80 out, and counter plus plus, so counter become 5, and then finally 100 will make us break the while, because 100 is not lesser than or equal to 85, and then we finally return 5 plus 1, which is equal to 6. Oh sorry, this is 4. And let's see if this works. 1112146, 1112146. Yes. And now we are jumping to the coding part. So counter initialized at 0, and while the stack is not empty, and stack the top is lesser than or equal to p dot first. for the price. So counter plus equal to stack dot top dot second and stack dot top, and then counter increment, and finally stack push current counter and price. So counter and price, and return counter plus 1. Okay, get accepted, and thank you for watching today's video. See you tomorrow. Bye bye.